Hello, I'm Aretha. This video is dubbed with English synthesized voice. This time, we will show you how to suppress the heat generation of 14,700 kF. I was searching overseas forums. I found a very great article. Try the method yourself. It was so wonderful. I would like all kinds of people to know about it. With that in mind, I made a video. Suddenly the Cinebench is running in the background. The upper row is running with load-optimized default set in BIOS. The bottom row is turning with the settings explained in this video. CPU package power has decreased by about 40 W. The clock is grouped together, so the numbers are half-baked. P-Core 5.5 GHz E-Core 4.3 GHz setting. The magnification remains as set by Intel. There is a huge difference in power consumption even at the same frequency. Japanese videos on YouTube. Heat generated is often talked about. There are few videos other than PL restrictions. So to the person who wrote that article, I asked if I could quote it and make a video. Thank you for your kind consent. If you can add English translation subtitles. I was even told that I would post the link. I have difficulty with English ability. I did my best to add English subtitles. I've decided to post it. First of all, I would like to thank the people involved in the article from which this quote was taken. RobertoSampaio for compiling and writing the article. Sorry for the other subtitles. I would like to express my gratitude to all of you. Sorry, there are many names that I don't know how to read. I'll get into the explanation right away. First of all, the premise is, this video was created with the aim of reducing heat generation through BIOS settings and making it easier to operate without reducing the performance of Intel's higher-end CPUs with K, and basically it targets mothers with Z chipset. In the original article, ASUS Maximus Z790 Extreme is used. I am using Gigabyte Z790 DDR4. This theory basically works if the mother is equipped with a Z chipset. It is probably possible to set this on any manufacturer's motherboard. However, we do not guarantee operation with all Z motherboards. Stability is defined here as stability in everyday use. Excessive loads such as one-day load tests using Prime 95 are not considered. In case of endless encoding, please make adjustments by yourself, such as performing additional tests. The environment this time is 14,700 kF, so we do not provide explanations or settings related to thermal velocity boost. Please check the source article for that part. The source of the quotation explains the significance of this setting. What kind of people is it aimed at? Why this behavior? Opinions regarding power consumption and CPU deterioration are also explained in detail. If I introduced everything, the video would be ridiculously long. If you are interested in those things, please check the source article. This video follows the steps listed in source number 2. The emphasis is on what you actually do in the video. Some details are omitted from the explanation. I think you can deepen your understanding by checking the source and watching the video. Let's actually do it. Let's talk about the machine configuration. CPU is Intel Core i7 to 14,700 kF. Motherboard is Gigabyte Z790 DDR4. CPU cooler is PCCOOLERCPS DE360. Grease is Fuse Plus. Other than that, it is as shown in the image. The OS used is Windows 11 Enterprise Evaluation English version. We are using the evaluation version here, but of course there are no major changes in the procedure for other Windows. First, install the OS. The source of the quote contains notes on Wi-Fi for recent models. When I try to install normally after upgrading to version 11, internet connection required. However, as it is, you cannot connect to the internet wirelessly. Let's deal with it with a USB memory with the driver installed. If it's too much trouble, try connecting by wire. Most certainly. This motherboard doesn't have Wi-Fi in the first place, so it's a wired connection. Next, after the OS installation is complete, install the various drivers. Each manufacturer has a program to assist with setup. If it's Gigabyte Control Center. If you install this, most drivers can be installed automatically. Once you have finished updating Windows and installing drivers. Next, we will install the programs necessary for verification. HW Info. CPU-Z. Cinebench. I think R23 is good for Cinebench. It's easy to tell when it freezes. Prime 95. OCCT. Real Bench 2.56. 3D Mark. IDA 64. Please add a program to perform equal load testing. Macrium Reflect. This is a drive cloning program. Unfortunately, the unlimited personal free version has been discontinued. The trial version that can be downloaded from the main site can be used for 30 days. The rest is the overclocking program released by the mother manufacturer. It is convenient to have Intel XTU. Once the programs have been installed and you are ready to system drive using Macrium Reflect, it is highly recommended that you create an image. It is possible that the OS may crash while you are working. In this case, files may be damaged. By saving an image using Macrium Reflect, quick recovery in case of OS corruption. It doesn't necessarily have to be Macrium Reflect. Any tool that can recover the OS from the image is fine. If you don't do this, you will have to reinstall the OS if it becomes corrupted. We recommend that you use some kind of program to prevent this. Are you ready? So let's start tuning the beast. Go to BIOS settings. The current BIOS state is load optimized defaults and the power limit is set to 253W. After this, the content is far different from the original image. Please be careful there. Z790DDR4 is in easy mode when you enter the BIOS. First change this to advanced mode. Go to System Info. You can see the BIOS version here. I will omit the steps for updating the BIOS. Please follow the instructions of each motherboard vendor if necessary. Go to Save and Exit. Save settings. With Save Profile you can apply settings saved in Load Profiles. If you can save 8 and want to save more, you can save as by selecting File in HDDFDD USB. If you want to save it to USB, it seems that it will not be possible to save it unless it is FAT32. Couldn't do it with NTFS. I think this varies depending on the motherboard, so please check for yourself. If you want to save the settings midway through, use this. Please note that you should adapt XMP only after all CPU adjustments are completed. No matter how strong XMP is, completely stable operation is not guaranteed. Therefore, various settings should be set as normal as possible. Change settings, start up and check stability. This process will be repeated. It is best to only change one place at a time. There are very few changes to be made in this step. Change and confirm one item at a time. Please do this thoroughly. The exception is when changing an LLC. Changing multiple items at once makes it difficult to identify the cause. That's something only experienced PC creators can do. Tune your CPU to run at the lowest possible power and temperature. This is done only by setting various load lines. This is the great thing about this step. There are very few setting items. Perform initial settings. Go to Twerker screen. First, set the various voltages to normal. I am setting it this time, but I think it is okay to set it to auto. Gigabyte motherboards may change the voltage automatically. I deliberately set it to normal. Next, configure the LLC. Enter advanced voltage setting. Enter CPU, VRM setting. There is CPU V core load line calibration. Set this to medium. I think other manufacturers often use something like level 1 to level 8. For the first setting, please select the item in the middle. I think it's around level 4. I don't think you need to touch CPU internal AC/DC load line. When I touch this, the AC load line settings seem to change. It is probably ignored because you enter a fixed value directly. Enter internal VR control. Enable IA/VR config enable. First, set the safety settings. Set IA/VR current limit. This will be the ICCMAX setting. Set 1200 here. This motherboard is designed to input 4 times the amperage. 4 times 300 amperes is 1200. The maximum amperage delivered to the CPU is now 300 A. Next, set IA/VR voltage limit. This is in millivolts, so set it below 1720. The voltage applied to the CPU is now limited to 1.72 volts or less. By making these two settings and setting the PL limit to 253 W, even if the settings fail, the CPU will not be physically damaged. Now let's configure a clothesline DC load line for their original purpose. A clothesline line sets 20. This will be 0.2 milliohms. Set D clothesline line to 58. Unfortunately, it seems that the LLC settings and D clothesline line settings are not linked on this motherboard. However, in rare cases, the automatic setting value of D clothesline line may be changed. Some settings seem to change automatically. This is 0.58 milliohms. Enter the resistance value according to the LLC level that you checked in advance. Checking the value of DC load line according to LLC is easy. Just adjust DC load line for each LLC and find the value where WinFOS core vids and vCore match under load. Gigabyte Z790DDR4 has a fairly low resistance value. Even at the lowest LLC setting, normal, the resistance value is only about 0.87 milliohms. This varies depending on the manufacturer and motherboard. It is recommended that you do your own research. If it is an ASUS motherboard, use the resistance value of Z790MAXIMUSEXTREME written in the quote source. I don't think there will be any problems using it. Something to note here is that, if you set a small value for DC load line and a large value for a clothesline line, there is a risk that a large voltage will be applied to the CPU and the CPU will be damaged. So try to keep a clothesline line lower than DC load line. We recommend that you perform the safety settings mentioned earlier to prevent such situations from occurring due to input errors. The initial settings are now complete. To make settings easier, set LLC ACLL DCLL and DC load line as favorites. Once set, you can immediately change the settings on the Favorite tab. Boot the OS and check stability. This time we will check with Cinebench R23. There are various arguments regarding stability confirmation. If I were to express my personal opinion, it would be because each person has a different purpose. I don't think there is one right answer. If you are using it for mission-critical work, please use the default state. Changing the settings itself is wrong. If you only use games for private use, I don't think it's necessary to spend excessive time on load tests. I think that many users will have no problem starting using Cinebench as long as it is stable enough to complete 10 minutes. It's just that there's no problem getting started using it. does not mean it is completely stable. If you are using it and an error or blue screen appears, try adjusting it again from the BIOS. If you want perfect stability, try Prime 95's smallest 4-foot. I don't think there are many processes that require that much load. I think it's worth testing if you're looking for perfection. For now, run Cinebench for about 5 minutes. If there is no problem, enter BIOS again. Lower the value of a clothesline. Let's lower it from 20 to 10 for now. Then restart the OS and run Cinebench. Then you can confirm that WinFO's vCore has decreased. By lowering the value of a clothesline, the voltage applied to the CPU has decreased. If there is no problem in the test, enter the BIOS again and lower the clothesline. Lower from 10 to 1. If it is 0, it will be treated as auto. The lowest setting is 1. Start up the OS again and run Cinebench. If it is stable even with a clothesline set to 1, make a note of the vCore being processed by Cinebench at this time. Now change the LLC settings. Change LLC from medium to low in BIOS. Adjust a clothesline DC load line accordingly. Set DC load line to 69 for this motherboard. I think a clothesline should be about 1/3 of DC load line. In this case, it's 23. This setting value varies depending on the motherboard. Please adjust by yourself. For now, save with these settings. Start the OS and run Cinebench. Check the vCore with HWinfo. Compare with the vCore value of a CLIAD Line 1 settings before lowering LLC. If it is high, lower the clothesline until it is about the same. If it is the same or lower, continue the load test. If it is extremely low, you may want to increase the clothesline value a little. It's still expensive. Lower the clothesline again. I think the value to lower is about 0.1 milliohm. Run Cinebench for about 5 minutes. Follow these steps until Cinebench gives an error. Turn Cinebench to lower a clothesline. If a clothesline is 1 but there is no error in Cinebench, remember vCore. Reduce LLC strength and adjust DC load line. Set a clothesline to about 1/3 of the adjusted DC load line. Start up and run Cinebench to check the vCore. If it is higher than the number you memorized earlier, lower the clothesline further. If it remains the same or has decreased, continue testing stability with Cinebench. This is repeated. Repeat this process to lower the vCore until an error occurs in Cinebench. If the LLC strength is set to the lowest level and the error does not occur even with the clothesline 1 setting, if you have a CPU with good low voltage tolerance, leave the clothesline setting at 1 and enter a negative offset with voltage offset. This will lower the vCore even more. Can reduce heat generation. This is effective when lowering the turbo boost multiplier than the multiplier set by Intel, due to the cooling capacity of the CPU cooler used, etc. I think it can be used when you need to lower the magnification. If an error occurs in Cinebench, increase the occlude line value little by little. In my personal opinion, I think it's best to run Cinebench for about 10 minutes when you get to this point. And if you find the lowest occlude line setting that Cinebench passes, increase occlude line a little from that number to have a margin. This completes a system with low heat generation and reduced performance degradation. Thank you for your hard work. According to the source, there are settings for overclocking and thermal velocity boost after this. Sorry, I haven't made it into a video. LLC ACLL DCLL setup by RobertoSampaio. CPU heat reduction setting. This setting can be done without advanced PC knowledge. I think it's a great procedure that is easy to set up. Of course, even Japanese PC creators. There are people who are implementing it. I couldn't find any articles or videos that explained it in detail in Japanese. I made it into a video. I will put a link to the original text in the summary. If you are interested, please take a look. Of course it's in English, but I don't think it's difficult to understand if you translate it. Finally, although it is not in the source of the quotation, let's talk a little bit about AVX. AVX instruction is a type of CPU instruction. Processing this instruction places a huge load on the CPU. Fever also increases. When you actually run an AVX2 load test using OCCD's CPU processing with the settings completed earlier, errors may occur. To deal with this, Intel CPUs have BIOS settings related to AVX. There is an item called AVX settings in advanced CPU settings in BIOS. Here we use a VX offset and a VX voltage guardband scale factor. A VX offset is used when performing specific AVX processing. This is a function to lower the CPU magnification. The numbers entered here will have a negative offset. If you enter 10, the CPU multiplier will be reduced by 10 during AVX processing. If you use this, you can lower the magnification only if AVX instructions are used frequently. A VX voltage guardband scale factor is. This setting determines how much VCore is additionally increased when processing AVX instructions. This setting ranges from 0 to 199, and the default value seems to be 100. If it is set higher than 100, the added voltage will increase. If it is smaller than 100, the added voltage will be smaller. While running a load test with a VX on with Cinebench and Prime 95 with the previous settings, I think you can understand if you look at WinFO's VCore. The voltage is quite high. Increasing the voltage will improve stability, but please be careful as it will also increase heat generation. I don't think you need to worry too much for general use. That's all. This video is based on the article written by RobertoSampaio. I hope this will help those who are actually trying to set it up. I will continue to post videos about PCs with English audio. Please support us by subscribing to our channel. Thank you for watching until the end.